Hey there, in this video we're going to look at what a function is and how we tell when something is or is not a function. So we know that a function, which can be represented as f of x, and that's how you say this right here, really means the same thing as y, or those can be interchanged in the case of a function. So when we see something like y equals, and we'll talk about what might be on the other side as we go through this unit, but y equals can be used or interchanged with f of x equals, and those can mean the same thing if we have a function. So a function is basically just a relation between two sets in which one element is taken from each set, and each input has exactly one output. And that's key there. So each input has exactly one output. So a function is a relation in which each input value has exactly one output value. So if x's are my input and y's are my output, each x value over here links to exactly one y value over on the other side of this table. And we'll talk more about different ways to actually represent functions here in a minute. But the graph of a function is a visual representation of just ordered pairs, like we see here in this table, x and y values that go together, that form that ordered pair, that make up the function, where the x coordinate represents the input and the y coordinate represents the output. And that is typically how we look at functions. So x being your input value and y being your output value. So there are many different ways that we can represent a function. So the equation y equals f of x is used to represent a function where f is the name of the function and x is the input variable. So x again is the input variable. Now functions can be represented in many ways. So we can see this entire table here gives us 5 different ways that functions can be represented. For example, we might see an equation, a set of ordered pairs, a mapping, a table, or a graph. So just to give you some examples, we see, especially with the ordered pairs, the mapping and the table, it's very easy to see which x coordinate maps with which y coordinate. For example, the ordered pairs. If you look at the x's, x is 1, 3, and 0 in this example I give you. And each of these representations are different. They don't go together. It's just showing you that there are at least 5 different ways that you can represent a function, whether that's the equation, the ordered pair, so on and so on. So if I look specifically at this example I gave you under the ordered pairs, we see 1, 3, and 0 as the x coordinate. 1 maps directly to a y value, 3 maps to a y value, and 0 maps to a y value. What would make this not a function, and I have some examples for you down below, but what would make that not a function is if we saw, for example, the x value 3 mapped to the y value 4 and to 5. So if the same x value mapped to 2 different y values, that would say that it is not a function. So what makes this original example a function is that each of these x values has its own y value. In other words, the x coordinate cannot repeat and have 2 different y values. I personally think that the mapping is probably one of the easiest, most visual ways to see the difference between a function and not. So if these are my input values over here on the left, and these are my output values over here on the right, if you think about each of these input values, they match to a y value. So -4 matches to -7, -1 maps to 3, 0 to -2, and 5 goes back to -7. That's okay. So it's okay to have 2 different x values that have the same y value. It is not okay if -4 also map to another number in addition to mapping to -7. So we see, for example, this one is a function because each input maps to only one output. But down here, we see inputs and outputs. We see 6 maps to 2 different outputs, and therefore this is not a function. So this one is a no, not a function, because the input x equals 6 maps to two different y values. So that can be visually helpful just to see and to maybe help understand what that actually means for something to be a function. Same with the table. We see this is really just like a mapping. I could even draw these bubbles or ovals and map each of these together. But we see down here in this table, -1 shows up twice in the x column, and it has two different y values. So -1 maps to 0, but it also maps to 2, which means that that would not be a function because the x value of -1 maps to two different y values. All right, and then we have some examples of equations that are and are not functions, and then graphs as well. So we can see that this graph is a function. It passes what we call the vertical line test, which just means if we can draw vertical lines literally anywhere on that graph, and every single vertical line that we could possibly draw on that graph only crosses the graph one time. So for example, in this one, it only crosses there. Here, it only crosses there. Here, it only crosses there. No matter where I draw it, it only touches that graph once, then it is a function. Whereas a non-function would not pass the vertical line test. So if I drew a vertical line somewhere on that graph, there's at least one spot where that vertical line hits two different points on that graph from that same vertical line. And this actually really means the same thing as the mapping, because if you think about it, this vertical line, these 2 points have the exact same x coordinate. So their x coordinate is -1 in both of these examples, but the y coordinates are different. So this one has a y coordinate of about 1.5, just for estimating sakes. And this one is also about -1.5. So those are two different y values. So the x coordinate -1 maps to two different y values, which takes us back to what we said with the ordered pairs, mapping tables, so on and so on. So the key thing to get out of this is when we are looking at a function, each x value has exactly one y value, no more than that. The ways to represent a function, we talked about equations, tables, mappings, graphs, and sets of ordered pairs. So coming up, we'll talk a little bit more about linear functions specifically, but a function in general, again, key thing is that each x value has exactly one y value.